Okay. Um, so this code right here is just, it's basically, if you know C++, I read the description for DCD. This is actually the first time I've seen this command, but it from what I can tell, it's kind of like new in C++. It's allocating a word. And so what it's doing, you don't have to write this code. This is part of the template, but when you call your function, you're going to call these variables right here. So like, for instance, array1, you're going to pass that, or not, well, not array1, but array1 pointer and array1 size. You're both going to pass those into your macro. I almost said function, but it works very similarly. So we'll use similar syntax, like we have the past couple of weeks. And so I'm going to go through just the basic logic of the solution, and I guess highlight some things that might not be so obvious. Second. Give me 1 second. Okay. So I think in previous labs, something that's going to be very useful with this lab as well is the Keel website that has all the definitions of the commands. So I mean, you definitely want to look up DCD to better understand how that works. But essentially, you're declaring variables that you can pass into your macro, and you'll pass them in just like we have in previous weeks. And so you want to make sure that you use just one macro to do it all. So you're going to have one macro that calculates the sum, that is like the sum of these, and then you're going to then in that same macro you're going to calculate the average, and it tells you down here where you're going to put those results. I think I am. Well, I'm recording now. Anyway, so the beginning of your macro, you're going to want to use, so some commands you're going to want to use that'll be useful are LDR, like we've been using in previous labs. And you want to use LDR, you want to put your array pointer and array size into a register. And so we actually won't be passing in array1. We'll be passing in array1 pointer, which is kind of, I don't know, that's kind of weird to me how they do that. It seems like you could just pass in array1, but that's what we're doing. We're passing in array1 pointer. And so the way this works is you essentially you need to load the array pointer and the array size variables that you pass in to a couple of registers. And then you're going to declare some variables within your macro. So sum and average could be, variables could be name. You don't have to choose that exact same name, but you're going to initialize those to 0. And then you're going to compare, well, I mean, you don't necessarily have to do this, but what the solution does is it compares the array size that you just loaded into a register with 0, and if it's equal to or less than 0, then it skips to the end. So I don't know that I think it'll still work without that, obviously, but that's just kind of a safeguard in case, I don't know, someone were to accidentally, it's not going to happen here, but if someone were to put in an array size that is 0 or less, it would catch it and skip to the end. I don't know. You don't have to put that. I won't take it off if you don't have that. So from there, it's pretty simple. You just want to calculate the sum, and then once you have your sum, you just divide the array size by the sum that you just calculated. And you want to load those into registers as described right here. And so how the solution, I'll tell you how the solution counts the sum. Now I believe you could use the method that we did, I think in lab 5, where we counted the sum of an array and we use SP. You could use that, but that's not, and I won't take off points for, there's not a lot of, like every lab, you just have to follow the restrictions, and there's not as, within the macro, there's not as many restrictions for this lab. So there's a lot of ways to skin the cat. But in the solution, they're using load, and they're using, I'll show you the exact instruction they're using. So to increment the loop, as opposed to what we did in lab 5 with the SB command and all that stuff, they're using this command right here to increment the loop. And so, early in our solution, as I don't know, you're probably, I'll put this on YouTube and you can rewind as many times as you want, but earlier I said that, we need to, basically what it's doing is it's taking the array pointer, and it's wherever you put your array pointer, wherever you initialize that to, you initially loaded it in, it's using this post index version of LDR. And so you can see that, you call LDR all these different ways and it has all these different behaviors. And so what's happening in the solution is that this post index format is what's being used. And so let's say if you initialized your array pointer to R0, you'll have R0 in here. And so what that does is that takes the address to R0, it puts it in RT, and then it increments this, R0 by a certain number. And so, when you call the command this way, it operates in a behavior that's called post index. And so what it does is it first loads the address into RT, and then it increments it. And for your offset, if you remember from, I think, lab 5, you want to choose 4. You want to increment it by 4 because that's how many words, or there's 4 bytes in a word in Keyalarm. So you want to use the number 4 to increment your loop. And then with that, you're just going to add, the number you have in here with your sum variable that you've already declared. And then another command, and I think I'm going to send out an email that just lists the commands you can use, because that way you can use um, the commands and just arrange them in the proper order, and it'll be correct. But after that, and there's a lot of different ways you could do it. You don't have to do it this way, but they use sub s, and they use sub s to decrement the array size. And then we've already talked about how s works, and it goes and it sets a flag. Then they use BGT, um, branch greater than. So if the array size is still greater than 1, then the loop starts again. And that's the most complicated part, is summing everything that's in that array. And then after that, the last part of the macro is to divide that sum by the array size. And you're going to want an auxiliary register for your array size, because as you go through your loop, you're going to be decrementing that auxiliary register. But at the end, you're also going to need your original array size to divide, you use that as the denominator when you divide the sum, to get the average. And so that's how they do it here. Any way that works is fine with me. If it doesn't violate the constraints in here, and they really don't give you any requirements for what you do inside the macro, and the answer is correct, then it works for me. But I think I'm going to send out an email, and then also, obviously with the link to this video, talking about some key helper commands that could be useful and how you'll use them. Because another one that, it'd be helpful to read, the page on it, it's called sdiv or sdiv. And that's basically the function they use to get the average, or divide the original sum. So it's a good question. So how do we account for the changing size of the array? So that's why you want to use an auxiliary register. So when you declare the macro, you bring these variables into the macro. You're going to have your where is it? Array size is going to get passed in. Okay. Now you're going to put that in a register with the LDR command. So you've got your array size sitting in R1. And so I'll tell you what the solution does is it decrements that R1 as it rolls through the loop. But then at the very end, it reinitializes R1, because once you pass in array size, that's like a variable that if you passed it in, unless you go and mess with that variable, like array size that you've passed in will stay independent of the register that you loaded into. So what they do at the end is they basically reinitialize it, and then use R1 to divide by the sum that has just been calculated. So they're using R1 as their auxiliary register. You don't have to use that one. That's what they used. But array size, because you didn't mess with it, stayed static. We were decrementing R1 as we go through the loop. And so, for instance, sum, which was also passed in and initialized to 0 at the beginning, sum is changed throughout the loop. So sum is not going to be the same at the end. But array size, since we didn't jack with it, we decremented R1, it's still the same. So you can they go in and they reinitialize R1 with array size. You could just straight up, you wouldn't even have to, you don't really even have to do that. You could just divide sum by array size if if you haven't jacked with the value. Does that make sense? Okay. Um, I'll post this video tonight, or if I don't get it out tonight, I'll get it out early tomorrow morning. And then I'll also include in the email just some of the key commands that they used here and how they're using them. Obviously, I can't just send out the solution, but I'll put some pretty good hints in there. Um, does that work? Are there any other questions? I saw Long in the chat. I was thinking Professor Long dialed in to Snoop or something. Guess not. All right. Well, I'm going to go ahead and end the recording if there are any more questions, um, and I'll get this email and post the video soon enough. Oh, so yeah, if one lab is dropped, so if you've done all the other labs, unfortunately, I haven't been able to. I'm not completely caught up on grading all mine, so it's probably smart to do this lab just in case you don't get a satisfactory score on one of the other ones. But um, yeah, in fact, I'll get the rest of the labs graded by Saturday. That way you can know, you know, I'll get caught up on labs by Saturday. That way you can know, if you have good grades on the rest of them, you don't have to do this one. You can just drop it. Uh, so that's a good point. I'll make sure to get caught up on all the labs at least by Saturday. Sound good? All right. Well, I'm gonna end the call now. Y'all have a good week.